Welcome back to Miss Eddie's Math Movies, where it's cute to be a square. Today's lesson is over section 4.5, the converse of the Pythagorean Theorem. By the end of the lesson, you should be able to identify different types of triangles using the converse of c squared equals a squared plus b squared. In the last lesson, we talked about the Pythagorean Theorem, which said if you have a right triangle, then you can do c squared equals a squared plus b squared. Well, today we're doing the converse. And the converse, if you remember from a few lessons ago, flips this. So we're going to flip it. So today we're going to say if c squared equals a squared plus b squared, then you have a right triangle. So we're going to determine if the triangle is right or not. Then it's a right triangle. If this is true, it has to be a right triangle. So, is ABC a right triangle? So we have to check. Is c squared equal to a squared plus b squared? So, look, if you see here, c squared question mark, a squared plus b squared. Are these equal? Well, let's check it out. Remember, C is the hypotenuse, or the longest side. So we're going to circle the longest side. So is 20 squared equal to 12 squared plus 16 squared? That's what we have to decide. So we're going to calculate. Make sure you can see that. There we go. All right, so 20 squared is 400. 12 squared is 144, and 16 squared is 256. Now, are these equal? Is 400 equal to 144 plus 256? Yes, it is. 400 is equal to 400. So it's true. C squared does equal a squared plus b squared. So that means this is a right triangle. Now, if this didn't work, it would not be a right triangle. It would be obtuse, or it would be acute. In example 1, how do you know which sides to use for A, B, and C? C has to be the longest one. Doesn't matter for A and B. A and B can be either, but C has to be the longest. All right. Is the triangle a right triangle? Explain your reasoning. So this means you have to show your work. You must show your work. So you're going to do c squared. Is that equal to a squared plus b squared? Oops, I'll leave this as a question mark because we don't know yet. So plug in those values and see if this works. Is it a right triangle? So make sure you find all the C's, the longest sides. And over here, you're like, well, how do I know which one's the longest side? Put this in your calculator. Square root of 39 is 6.2. All right, so A is the longest. Here, 14 is the longest, and here, 29 is the longest. So that's your C value. So substitute and see if it works. If it works, it's a right triangle. If it doesn't, it's not. So what happens if it's not a right triangle? Well, we know if it's equal, then it's a right triangle. All right, but let's imagine, what if c squared was smaller? So here, I want you to imagine this right triangle, okay? And here, let me use this, I'll just look at it like this. If C, here's C, imagine you see C right here. If C is smaller, if C gets smaller, what kind of triangle do we have? This is not a right triangle anymore. This is an acute triangle. And what if C squared gets bigger? So watch. Here's my right triangle. Here's C. If C gets bigger, then we don't have a right triangle anymore. We have an obtuse triangle. Look at this. This is an obtuse angle. So if c squared is smaller, it's acute. If c squared is equal, it's right. And if c squared is bigger, it's obtuse. We've already talked about this one. We have to talk about these other two now. We'll do some examples. Show that the triangle is acute. All right, so we need to find our c value. I'm like, I wonder which one is the biggest. Well, let's put square root of 35 in our calculator and see. The square root of 35 is approximately 5.9. So that's the largest of these three sides. Square root of 35 is the largest, so that's our c value. So now we can check to see if c squared is equal to, greater than, or less than a squared plus b squared. So I'm going to put square root of 35 here, because that's my largest. Then it doesn't matter between the other two what I use. So I'll do 4 squared and 5 squared. I'm going to compare to see what I find. Well, the square root and the square cancel each other out. So this is 35. 4 squared is 16, and 5 squared is 25. So now we have 16 plus 25. Over here, this is 41, this is 35. Well, 35 is smaller than 41. Since C is smaller, that makes this triangle acute. We have verified that it is acute. Now here's one where they don't tell us what it is, and we have to figure it out on our own. Once again, 8 is the largest. We always have to identify that. Then we're going to plug this in and compare these values. So c squared is 8, a is 5, and b is 6. These two don't matter. Now 8 squared is 64, 5 squared is 25, 6 squared is 36. All right, now it's time to compare. 25 plus 36 is 61. This is 64. 64 is bigger. C squared is bigger, which makes this triangle obtuse. So you compare the numbers and decide what kind of triangle it is. So that's what you're going to do over here every time. C squared, you're going to compare that to a squared plus b squared. And then depending on what it is, you classify the triangle. So if it's equal, it's right. If c is smaller, it's acute. If c is bigger, it's obtuse. Make sure you're always finding the largest side. So here it doesn't matter which one's the largest, they're all the same. Same thing here, here's your largest, largest, largest. And every time you're comparing c squared to a squared plus b squared. So I want you to substitute and compare and then tell me what kind of triangle it is. And we will check this tomorrow. This is M cubed, signing out.